All right, I'm going to be working here on 12.8, which is change of variables, working problem number 15. And I put some stuff up here to remind you. First of all, what we're doing is we're doing the double integral over the region R of x minus 3y with respect to area. So we're back to double integrals right now. And the region that we're given is the triangle with these vertices. And we're also given that we're going to use this transformation to somehow convert this region into hopefully something that's nicer. Now, this region by itself could be done. I mean, this is possible to split this up right here and do it as a type 1 region and do two of them. So like here, we could do this as a type 1 and do that one as a type 1, add the two answers together. But the whole point of change of variables is to try and get a nicer region from an ugly region. So these are given to us, and that's a big deal that they're given to us. So the question is, what does this become in the transformation? So we're trying to convert that region in the xy plane to the uv plane, and hopefully it'll be a nice region. So let's start out by, let me move these a little bit. X equals 2u plus v, y equals u plus 2v. All right, give myself some room here. So let me first ask, what does this line become in this transformation over to here? So let's find the equation of that line. It has a y-intercept of 0, has a slope of 2 over 1. So this should have the equation y equals 2x. So what I'm going to do is I'm going to take that information, y equals 2x, and I'm going to rewrite this equation, replacing y with my substitution, replacing x with my substitution. So the left side is y, which is u plus 2v, must be equal to 2 times x. X is 2u plus v. And then I will multiply things out. U plus 2v equals 4u plus 2v. Notice I can subtract 2v from both sides. I get u equals 4u. Subtract u on both sides. 0 is 3u. Divide by 3, you get u is 0. So what I know is that this line, okay, gets taken over. And remember, the line extends forever, but this line segment would be taken over to the line u is 0. So over here in the uv plane, if u is 0, then I imagine having a line over here, vertical line, u equals 0, that would extend forever like this. Okay, now what I'm going to do is I'm going to look at, let's take another line segment, which would be this one. Find the equation of that. So it has a y-intercept of 0, it has a slope of 1, 2, so it's a slope of 1/2. So that's just 1/2 x. Now I'm going to do the same thing. I'm going to ask myself, what happens to 1/2 x, or y equals 1/2 x? What does that line get taken to? So I'm going to write this down right here. Y equals 1/2 x, and y is u plus 2v. 1/2 x is 1/2 times x, which is 2u plus v. And that's u plus 2v equals, distribute the half through, u plus 1/2 v. Notice I can subtract u on both sides and they're gone. And then I can move all my v's to one side. So I'm going to add a half v to 2. That's going to give me 5/2 v must equal 0. And then just divide through by the constant, v must be 0. So this line gets taken over here to v is 0. V is my coordinate this way. So v being 0 is the line going like this. And then the last thing to do is to figure out what's happening here. So if I extend that up forever, we can tell the slope of this is down 1 over 1, right? Down 1 over 1. So the slope is -1. The y-intercept, we should hit up here at 3. So that should have the equation y equals -x plus 3. And I'm going to see if this marker is any darker. Write that down. Oh yeah, y equals negative x plus 3. So y is u plus 2v equals negative. Now x is 2u plus v, then plus 3. So u plus 2v equals negative 2u minus v plus 3. And here, neither one of the variables are going to cancel. So move all my variables to one side for right now. Add 2u, I get 3u. Add v, I get plus 3v equals the 3 that's over here. Divide everything by 3, you get u plus v is 1. And then what I'm going to do is I'm going to solve this for v. And so that's v is kind of like the y-axis is over there. So solving for v is like solving for y over here. So this is a line. It has not a y-intercept, we call it a v-intercept of 1. And it has a slope of negative 1, so down 1 over 1. And there. So you can see, I think it's obvious, that this region here, R, gets transformed into this new region over here, which we call S. And that S is a very clean type 1 region. What we have is that U here is between, actually it's not, yeah, it's type 1. U is between 0 and 1, and V is between a top function and a bottom function. Top function, remember this line right here, was V is negative U plus 1. So my V is stuck between negative U plus 1, that's the top, and the bottom was V is 0. So everything's looking good so far. What I need to do now is convert the integral over, the double integral. And so for this double integral, it's going to go from integrating over R to integrating over S. It'll be this function with this substitution in it. So it'll be x, which was 2u plus v, minus 3 times y, which was u plus 2v. And then I'm going to have with respect to area, but I have to put the Jacobian determinant in there. So I've got to figure out what this is, and I've got to place that right here. And then I can say, you know, du dv. So let's do our Jacobian determinant. I'm going to do that right here. So I need the partial of x with respect to u. So I look at here, partial of x with respect to u is the derivative of this with respect to u. I treat v like a constant. That's just going to give me 2. So this right here gives me 2 times partial of y with respect to v. So partial of this with respect to v is just 2 again, minus the partial of x with respect to v. Partial of this with respect to v is 1, times partial of y with respect to u, which again is 1. So you get 4 minus 1, which is 3. So I'm going to take all of this, I need another parentheses here, multiply it by the Jacobian determinant, which is 3, and then I can put du dv, or dv, oh, I have to do dv on the inside, du on the outside, because I have constant here and functions there. And then I'll erase this s, and I'll put 0, 1, and I'll put 0, negative u plus 1. Let me clean this up. Integral, double integral. Zero to 1, 0 to negative u plus 1. Let's see, I have 2 u's. I'm going to take away 3 u's, so I've got negative u. I've got v, and I'm going to take away 6v. I've got minus 5v. And then I have a 3. Oh, that 3 is going to multiply through. Or I can just pull the 3 out. That's fine. And then dv du. Okay, let's find the antiderivative. So I have, this is 3 integral 0 to 1. antiderivative of this with respect to v is negative uv minus 5 halves v squared, evaluated from v equals 0 to v equals negative u plus 1 du. And now I just replace. I think I'll do something else also while I'm here. These are both negative, so I'm pulling negative out, make this a negative 3, make that positive, make this positive. So we've got negative 3, integral 0 to 1, and then let's replace v with this. So I get u times negative u plus 1 plus 5 halves v squared. Nothing gets replaced in there. And then minus, we replace, oh wait, hold on, v squared, that I'm replacing v, oops. This is negative u plus 1 squared, sorry. Now what we do is we plug in 0 for v, so that's gone, so I don't have anything there. Du. And this is equal to negative 3 integral 0 to 1 of, let's see, negative u squared plus u. It's just distributing here and here. This right here, if I square it, I get u squared minus 2u plus 1. That's what I get when I square this out. And then I multiply 5 halves through. So I'll save myself some time. If I multiply this through by 5 halves, get 5 halves u squared minus 5u plus 5 halves. And I'm going to integrate each one of those. So I'm going to get 5/6 u cubed minus 5 halves u squared, and then plus 5 halves u. Oh, shoot. You know what? I wasn't integrating yet. Oops. I'm just simplifying. Okay. I'll do integration on the next step. I'm getting ahead of myself here. Okay, that's just everything multiplied out, du. Now I will integrate. I believe I can combine some like terms together, though. Let me see. Maybe I should combine like terms first. Negative 3 integral 0 to 1. How about as far as halves? U squared, so I can put those two together, and I should get 3 halves u squared. I can put the u's together here. That's going to be minus 4u. And then I have the 5 halves out there still. Du. Now integrate. Negative 3. Okay, antiderivative here is 3/6. So that's just going to be 1/2 u cubed minus 2u squared plus 5 halves u. Evaluating this, u equals 0, u equals 1. So when I plug in 0, everything's gone. But when I plug in 1, I should just get some fractions in here. So I get negative 3, let me see, 1/2 minus 2 plus 5 halves. And if I put 1/2 and 5 halves together, that's 6 halves, that's 3. 3 take away 2 is 1. So you should just get negative 3 times 1, which is negative 3. All right, there it is. All right, the next one I want to do, 17. So for 17, well, you know what? Let's do 16 first. I'm going to do 16. Double integral over r of 4x plus 8y dA. And we have a parallelogram that has the following points as vertices. Negative 1, 3. There. 1, negative 3. Here. 3, negative 1. Here. And 1, 5, which is up here. There we go. So I'm going to write down what these coordinates are. Negative 1, 3, 1, 5, 3, negative 1, and 1, negative 3. Oh, also, they give you the transformation. The transformation we're going to use is x is equal to 1/4 u plus v, and y is equal to 1/4 v minus 3u. Oh, wow, I have a meeting in 15 minutes. Okay, so I'm going to try and work quickly through this. All right, so let's figure out figure out what the lines are on these. This right here, this line is a y-intercept of 0, has a slope of down 6 over 2, so negative 3x. All right, and then this one right here, let's see. To find the slope, I can find the slope between these 2 points. So it's y2 minus y1 over x2 minus x1. So if I do this minus this, I get 2. And then this minus this, I get 2. So the slope of that's 1, so that's y equals x. And then I need the actual y-intercept of this. So the slope is 1, right? Up 1, over 1, up 1, over 1. Then if I go down 1, over 1, I should be here at negative 4, so minus 4. This line right here should have the same exact slope as this one because it's a parallelogram, but you can check it yourself, it does. Y equals x, but the y-intercept here is actually 4, so plus 4. And then this one right here should have the same slope as this one. You can check for yourself. Y equals negative 3x, but the y-intercept is actually, where are we? If we're here, 1, 5, then I'd go back 1, up 3, 1, 2, 3. So we would be actually at 0, 8. So this should be 8 there. Let me just double check that. Yeah. Okay, so now let's take a look at what these look like with these transformations. So if I let's take this one first, okay? Y equals negative 3x means that y, which is 1/4 v minus 3u, must equal negative 3 times x, which is 1/4 times u plus v. So we get, I'm going to multiply both sides by 4, and that'll get rid of those. So I get v minus 3u equals negative 3u minus 3v. My 3u's cancel, and then if I move things around, I'm going to get v as 0. So I know in my uv plane, one of the lines I have is v is 0, which is this. Okay, and now I take the next equation, which I'll do this one, y equals x minus 4, and rewrite that one. So y is 1/4 v minus 3u equals x, which is 1/4 u plus v, and then minus 4. I'll multiply both sides by 4, it'll go away, and then this will become 16. So v minus 3u equals u plus v minus 16, and then The v's will cancel. I can move the u over there. I get negative 4u equals negative 16, so u is 4. And if I graph that over here, remember this is the u v plane. U is 4. It's like this. And I keep this thing going. Now let me do this one. I rewrite this. Y equals negative 3x plus 8. So y, which is this, equals negative 3x. So negative 3/4. That's that, u plus v, then plus 8. So if I multiply everything by 4, I get v minus 3u equals negative 3, right? Because the 4 will cancel. Negative 3 times that, so negative 3u minus 3v. Multiply that times 4 plus 32. What cancels? 3u's cancel. And move this over, I get 4v equals 32, so v equals 8. So v is 8 is going to be, this is going to not be drawn to scale. Well, I'll just move it up. There's v is 8. And this one goes up there. And then finally, if I do this one, x plus 4. So I get y equals, here's x plus 4. Then multiply everything by 4. V minus 3u equals u plus v plus 16. Yeah, v's are gone. You get negative 4u equals 16. So u equals negative 4, which means u is negative 4 is over here. And you get this. So you can see that this region, this parallelogram, region R, gets transformed into this region over here, S, which is a rectangle, which will be very easy to integrate over. So now what I'll do is erase all this crap and roll over R. Okay, I'm going to set up my double integral over the region S, which is that. Now, I'm going to need to get my Jacobian determinant. So I'm going to have to calculate partial u with respect to x. Partial x with respect to u times partial y with respect to v minus partial, really doesn't matter what order you go in here with the multiplication, partial x with respect to v, partial y with respect to u. Okay, so I'm doing that now. Okay, so here's my partial, here's my stuff up here. Partial of x with respect to u, you can do that, you get 1/4. Partial y with respect to v, you get 1/4 again. Just distribute the 1/4 through, and then you'll have 1/4 u plus 1/4 v, and then here 1/4 v minus 3/4 u. Then the derivatives are real easy. Minus partial x with respect to v, which is 1/4. Then partial of y with respect to u, which is negative 3/4. So this is going to give you 1/16. Negative negative is plus. 3/16, which is 4/16, which is 1/4. So I know that I'm going to have a 1/4 I'm going to have to put in here. I have to rewrite this in terms of this. So what's 4 times x? Well, it's 4 times this. The 4's go away. You just get u plus v. What's 8 times y? Well, it's 8 times this, so 8 over 4 is 2. Distribute a 2 through. You should get 2v minus 6u. Now, that's this replaced. Now, the Jacobian determinant, which is 1/4, I'll pull that completely out because it's a constant. I can do that. And then I need my 2 variables. And since it's a rectangle, it doesn't matter which way I go here. I'll do dv du. My restrictions on u are -4 to 4. My restrictions on v are going to be 0 to 8. I can clean this up and make that -5u plus 3v. And at that point, you should be ready to go. I won't do the rest, but you would get an answer here if you work this out of 192. Okay, I've got to get to a meeting, so gotta go.